All right. So we've got chapter 6 and we're doing day 1 here. So technically 6-1. If you're following along with the book, it's technically 6-3, but we are just talking about piecewise functions, so there you go. So piecewise function is a combination of one or more functions and we're talking about the rule or equation is different for different pieces of the domain. So as you go through the graph of something, it's different based on where you are on the domain. So for instance, as you can see here, our equation is one graph here, and then it separates to be this graph here, and then separates to be that graph there. So we do have kind of this set of ideas, and the way that you portray that is with a system, if you will. And so the system says, hey, it's x squared, so it's this one, but only if x's are less than 1. And so notice that it stops here, and it should have an open circle there, but anyway. And then over here, our y equals 3. Over here, our y equals x squared, so our y equals 3, and it's between 1 and 2, right? So it's between this part and this part on our domain. And then the last one goes to a linear equation, and so it's y equals x, and it's y equals x when it's greater than 2. So greater than 2 on the domain. All right. So that's kind of the introduction. So what you're going to do here is evaluate a piecewise function. So what does it mean to evaluate? Evaluate usually means plug in, find a numeric answer. And so we're going to plug in a -1, and we're going to plug in a 4. And so what does that mean for the equations? Well, if x is -1, -1 is less than or equal to 2, and so we're going to use this equation when x is -1. And then this one says x of 4, and 4 is greater than 2, and so we're going to end up using this equation when we have a 4 plugged in. So that means that to solve for y of this first one, or find h of -1, the function at -1, we're going to end up solving 2 times -1 plus 1, which means -2 plus 1, which means -1. And then the other one we're going to solve by plugging in a 4, so 4 squared minus 4 makes 16 minus 4, or 12. So those are our evaluated pieces. So the next piece is a step function. So it is a piece or a set of pieces of functions, but the idea is that they're like steps, and so they end up being a constant or a horizontal line for each interval. So for instance, as we look at this first one, we're saying that y equals 5. So it's a line at 5, 1, 2, 3, 4, 5. So here, potentially. But notice that it's saying if 0 and 13 are its lowest and highest values. So I'm actually going to make a scale for this. So 0, 10, 20, 30, 40, 50, 60, anyway. And so between 0 and 13, we're going to have y equals 5, which means that I'm going to stop it here at 0, and then stop it at what I can estimate to be 13, so it's maybe about there. Also, as we're graphing this, we are going to note that these are open circles at the endpoints, because we're talking about it not actually including that 13 or that 0. The next one here is at 9, so it's 5, 6, 7, 8, 9. So it's a horizontal line at at 9, but that's between 13 and 55. So if we erase that, we're talking about it starting there and then ending at 55. So where's 55? Right there. You'll notice that 13 needs to be a solid circle because it's got an equal to part, but 55 is going to be an open circle, which I did not just draw. Sometimes you got to be very deliberate with your open circles. And then the last one says it's at 6.5, so if that's 5, 6, 6.5 is here. But I'm not going to keep this whole equation. I'm going to limit it to when x's are greater than 55. So I'm going to erase all of this until I get to 55, and then it goes on forever after that with a solid circle to show that 55 is included. So that's a step equation, and hopefully you can kind of see how that looks like a very terrible set of stairs, but that's the idea. Alright, then in our fourth example here, we're just going through and seeing how it is that we graph these. So potentially you're just graphing the equation as it is, but then you're erasing it based on what the limitation there is. So this first one here is intercept at 3 and a slope of 1 over 4, so up 1 over 4. And so that's my equation, but we're talking about, oh, I suppose I should make a line. Bad line, but there it is. Now I'm going to restrict it to x's that are less than 0. So x's that are less than 0 are over here, and you'll also know that 0 is not included, so I needed to erase that 0 point and make an open circle. Then for the next one, I'm looking at y equals -2, meaning the slope is -2 over 1, intercepting at 3, and so that's where this one actually leaves off, so that's nice. Intersects at 3 and then goes down 2 over 1. And it says it does it from x at x is less than 0. Or equal to. Oh, sorry, that was supposed to be greater than. I was like, that's not going to be helpful. So potentially this entire thing would be our line, but remember that we're only starting at 0, and so it's going to be 0 and on. Alright, and then this last example here, same idea. We're just going to graph this equation of y equals -3x plus 0 in this case, so starting at 0, down 3 over 1, down 3 over 1, etc., up 3 over 1. And then we're looking for this line, but then I'm going to erase based on this saying we want x is less than 2. And so that means at 2 on the x-axis and less than that, so I'm going to erase the point at 2 so that I can put an open circle. And then the next one picks up and it says y is 1 over 1 for our slope, x plus 3, so intersecting at 3, going up 1 over 1. And potentially down 1 over 1, but it says we want it greater than 2. So I'm going to start at 2, oh, and it says equal to, so I'm going to make that a very large dot, and then go up. There we go. And so again, sometimes there will be jumps in graphs, and they won't necessarily look super awesome, but that's actually more of a real-life scenario. The scenario that I think of a lot when I think of these types are like ticket sales. So for instance, a ticket could cost $5, it could cost $9, or it could cost $6.50. But there's never going to be a $7 ticket unless it's like a completely different day and they're having a sale or something. So the idea is that there are kind of regimented outcomes that could happen over certain scales. So for instance, if we look at this as like movie ticket sales, we're saying it's $5 for children, 0 to 13, right? It's $9 for adults, but then $6.50 $6.50 or 6.5 for 55 plus. So that's kind of what it's saying here. It's saying these are the prices of movie tickets, and it can't ever be anything in between. Your bill could be more than that, but per ticket, it could only ever be these numbers. So anyway, piecewise seem to be a little bit more applicable to what we see, which is changing over time, or age in this case.